Conic sections, sheet 3. If we have a quick read through the question before we start, the figure below shows the focus F of a parabola and the directrix, the direction of the axis. The position of a point P on the curve is also shown. So we have our main axis, we have our focus, and we have a point on the curve. Show how the directrix and vertex are located and draw a portion of the curve to include point P. Draw a tangent to the curve at point P. First of all, I'll always just notice when I come to a conic sections question, I'll note a couple of little things, okay? The eccentricity of a parabola is equal to 1, which means PF over PD, point to focus over point directrix, is equal to 1 over 1. Now, that's the first little thing I'll take note of, because just if I'll know that if it's a parabola, an ellipse, or a hyperbola, I'm going to have a different eccentricity, and I'll have a different ratio of the distance from point to the focus and point to the directrix. This ratio changes for each one. So in this case here, parabola, nicest one to work with, equal distance. Basically what that means is from any point on the curve to the focus is the exact same distance as that same point on the curve to the directrix. So to set that up, we just take our compass from that point, we set whatever that distance happens to be and swing it. So the directrix is straight over there. Someplace we have the direction of the axis this time, so we can just go straight across. And that gives us a point on the directrix. The directrix is always perpendicular to the axis. So there's D1, the directrix. The distance from point to the focus is equal to point to directrix. Next, the line of eccentricity for a parabola is 45 degrees, slope of 1. But we don't actually need the line of eccentricity this time. We could do it using our 45 degrees up, and then from the focal point, a small rule that's common to all conics. If we go 45 degrees from a focal to hit the line of eccentricity and drop straight down, it gives us a vertex. We don't actually need to do all that though, because we know that the vertex is a point on the curve and it's equidistant from the directrix and the focus. So it has to be halfway between the focus and directrix. So I might just go ahead and bisect that little line right here. And when I bisect that little line, I've just constructed a point that is the same distance from the focus and the directrix. So there's the vertex. Draw a portion of the curve, so show how the directrix, that's okay with that done. Show how the vertex is located. I could have used my eccentricity line, but instead I'll just use my knowledge that point to focus is equal to point to directrix. Draw a portion of the curve. Now we could of course again eccentricity line and lattice rectum and stepping out our ordinates. We could do that, or just a slightly different method here. I might plot this out here with a colour. Let's just go with 10, 20, 30, 40 and 50. There. So that is points A, B, C, D and E. Now I want to find the point on the points that are on the ordinate A and on the ordinate B. So I'll just draw all these double ordinates first of all. I want to find all these points. The method that we're probably used to doing is just to draw the line of eccentricity and bring them up, hit the line across onto the lattice rectum and swing them back down and so on. But you know, just using, again, it's just using this knowledge of the point focus and point directrix. The distance from the directrix to A, and that's any part, wherever A happens to be up along, the distance from the directrix to A has to be the same as the focus to A. So there we go. There's first 2 points in the curve. The distance from the directrix to B has to be the same as focus to B. There's the next 2 points in the curve. Now, I'm sure as you probably imagined, this will not work as straightforward as this for an object, for a curve, if the point focus, point directrix isn't 1/1. We're dealing with equal here. So the distance from the directrix to point C and from the focus to point C, we're constructing it as an equal relation. Distance out to D, and then from the focus up and down to D, and finally out to E, and from the focus to E. So what we can see there is, let's just take this very final point I just mapped out right there. The distance from E to the focus is the exact same as E to the directrix, just by using my compass. Now I probably could put in some extra points in there as well. I might as well actually, and you know what, the best one to add in there is just actually for the on the latus rectum. So the distance from the vertex into the focus is the same as the focus up to the points, up and down. So there's enough points really there that I can go with. And it goes straight through point B. There we are. That's that question finished. I'll move on now to number 4.